ऑलराइट, सो पहले तो इधर ही रखे ना, मैं थोड़ा एक्सप्लेन कर दूं। आप लोग भी जरा थे देखने, थोड़ा सा आके 1 मिनट के लिए आ जाएं, थोड़ी देर के लिए सारे लोग 10 मिनट के लिए आ जाएं जरा, बाद में आप रिकॉर्डिंग देख लीजिएगा, थोड़ा सा 10 मिनट के लिए आ जाएं। So basically, I just wanted to explain how a transistor works. So this is uh, the basic MOS transistor, which means metal oxide semiconductor. So this is metal oxide semiconductor transistor. So we have this has three components. One is called uh, drain, which is like VCC. Drain is VDD equal to VCC in bijunction transistor. I'm not going to explain bijunction transistor. So this is our source, which is equal to VSS, which is also called ground. So these are metals. So what happened is that in 3D dimension, if you look at it from the side point of view, it is like this. But you have metal contact here. You have a N-type material here. N-type material is the one which has excess electrons in semiconductor. इधर आ जाए आप लोग भी जरा 2 मिनट के लिए सिर्फ. So it has excess electron in semiconductor. This is a P-type state is called. So what happened that this is metal, which is a source, and drain. They are both equivalent, and on this there is a when they oxidize this, this becomes silicon dioxide, which is very high grade insulator. So you have one source over here which is called gate. No current can flow, and on this gate we have metal layer. So silicon dioxide, so silicon dioxide and metal. So that's why it is called metal oxides semiconductor. Metal, silicon dioxide is called oxide, and this is semiconductor. So this is called metal oxide semiconductor. Okay, right? So these semiconductor has excess electrons. They are gathered here, but there are no free electrons here, so that the current needs some free electrons to flow. So when we apply through this gate, when we apply some positive voltage, that attracts these electrons. So when there are plenty of electrons connected between up and down, these are attracted here because of the static charge. They are not here because of anything. They just here like a capacitor. कि अगर यहाँ पे आपके पास पॉजिटिव चार्ज होगा तो नेगेटिव चार्ज हो जाएगा. इनके यहाँ इकट्ठा होने से उल्टा काम क्या होता है? क्या काम हुआ? उल्टा काम क्या हो गया? ये इलेक्ट्रॉन का इधर से कनेक्शन बन गया और करंट स्टार्ट टू फ्लो. गेट का गेट सिर्फ यहाँ पर ये सेमीकंडक्टर है, ये वाला सॉरी ऑक्साइड है, which is very high, you can say insulator. So here we have a demo for this. मैंने थोड़ी सी आप लोगों के एक डेमो भी बनाई है कि this is a demo, as you can see. So on top and bottom view we have drain and source. नजर आ रहा है? top and bottom, we have drain and source, and these are free electrons. And since they repel each other, there is a gap. They cannot connect to each other. So what I need is something that can attract free electrons in the channel. This is called the channel. In the channel, so that the connection can be made. This is a kind of X-side. No mechanical, no metal contact, right? So when I bring a gate here to attract these electrons, what happens is that so these electrons join here, and what they do is यहाँ से थोड़ा connection lose हो गया लगता है. तो ये टूट गया, सॉरी, तो ये टूटा हुआ. ये आ रही नहीं चलना तो चाहिए इसकी. चल बात से ये किधर लंबी बात. Yes, you did. So when I now the connection is made, and this is running. This has only attracted these electrons here. So the connection between the top and bottom drain and source is made. When I move this, you can see here the connection is gone. When I connect, the connection is again made. When I remove this, connection is gone. Connection चल रहा है, नजर आ रहा है. So this is basically, this has helped in collecting these electrons here. नजर आ रहा है आपको? आगे से हट जाए ना, उनको तो देखने आया नजर आपको ना. ये इसको हटा देता हूँ तो ये बंद हो जाता है. ये तो इसको मैं लगाता हूँ तो ये इलेक्ट्रॉन अट्रैक्ट होते हैं और वो कनेक्शन ऊपर से नीचे. सही है, समझ आ गया आपको? चैनल में हाँ कोई भी यूज कर सकते हैं. बेसिकली ये सेमीकंडक्टर पी टाइप हो सकता है या एन टाइप सेमीकंडक्टर. हाँ तभी तो बनेगा, वरना उसमें फ्री इलेक्ट्रॉन होते हैं या होल्स होते हैं. पढ़ा हुआ है आपने कुछ सेमीकंडक्टर्स को? तो ये देखिए, आपके सामने बड़ी अच्छी एक एग्जांपल है कि किस तरह से ये कंडक्शन होती है इनसाइड अ ट्रांजिस्टर. अगर मैं ज्यादा बड़ा यहाँ पर वोल्टेज ज्यादा रखूं, और ज्यादा यहाँ पे इकट्ठे हो जाएंगे, और ज्यादा करंट इसमें से फ्लो कर सकेगी और ज्यादा हैवीली. तो बेसिकली दिस द होल आइडिया. ये वाला जो है, इसका इसके साथ इनके साथ कोई ताल्लुक नहीं, बीच में प्लास्टिक है और ये उनको सिर्फ जोड़ के कनेक्शन कर. ठीक है, तो दिस इज वाज द आइडिया ऑफ सेमीकंडक्टर मेटल ऑक्साइड सेमीकंडक्टर ट्रांजिस्टर. क्यों भाई, आप में से जो ऑनलाइन है, क्या समझ आ गई आपको? ऑनलाइन पीपल, आवाज आ रही है?
Yes,
हेलो,
sir.
अच्छा, आ गई समझ आपको? सही नजर आ रहा था? हेलो।
जी सर।
ऑलराइट, तो ये बेसिकली ये एक मैंने डेमो बनानी थी टू शो यू कि किस तरह से ये ट्रांजिस्टर कैसे काम करता है इन फ्लैश ड्राइव। फ्लैश का भी थोड़ा सा बता दूं मैं कि किधर गया बताने वाला, रब करने वाला ये। So in a flash drive, what happens is that here we have a very uh, small area of semiconductor, and this is all surrounded by uh, pure silicon dioxide. ठीक है, समझ रहे हैं आपको? This is all surrounded by pure silicon dioxide. So when you want to program your ROM, what you do is very high voltage across this. So what happens is that somehow some of the electrons, they cross this silicon dioxide boundary and get into this. When they enter here, they plus positive poles over here. And because of positive, there is a connection between this and this. Now, when I remove this, these electrons stay there. They can stay there for 20 years. So basically, they are there in solitary kind of confinement. इधर से निकल ही नहीं सकते, चारों तरफ इतनी सिलिकॉन डाइऑक्साइड की इंसुलेशन है कि ये निकल नहीं सकते अब इसके अंदर से। तो यहाँ पे जिसमें चार्ज इलेक्ट्रॉन स्टोर्ड है वो ट्रांजिस्टर ऑन हो जाता है, लॉजिक 1 स्टोर हो गया। जिसमें चार्ज नहीं डाला आपने वो ओपन रहता है, लॉजिक 0 स्टोर हो गया। तो वाइस वर्सा जो भी है, तो इस तरह से कंटिन्यू ये अब 20 इयर्स ये वाले इलेक्ट्रॉन यहीं पे रहेंगे। अगर आप इनको यूवी लाइट इन पे फेंकते हैं तो दे गेट वेरी एक्साइटेड, ब्राउनियन मोशन इनकी तेज हो जाती है। नहीं, जो भी है अरल इनकी मोशन स्पीड अप होती है एंड दे एस्केप फ्रॉम हियर। तो यूवी लाइट से एस्केप हो जाते हैं ये, फिर दोबारा से आप इसको प्रोग्राम कर सकते हैं। इनको टाइप हमने हाई वोल्टेज देते हैं 11 वोल्ट या 12 प्रोग्रामिंग वोल्टेज होती है स्पेशल, वो इससे देते हैं। तो इसको एक बाहर एक कंडक्टर होता है और इसका जो है ना एक अंदर कंडक्टर होता है। ठीक है, तो जब 12 वोल्ट देते हैं तो फिर ये सिलिकॉन डाइऑक्साइड को तो जंप कर जाते हैं। इसके साथ कोई लिंक नहीं है, ये तो बेसिकली ये यहाँ पर इनका लिंक यही है कि इन इलेक्ट्रॉन के जो ट्रैप हो गए उनकी वजह से होल्स यहाँ पे इकट्ठे होते हैं, वो उसको सर्किट बना देते हैं। बेसिकली ये सर्किट बना देता है और ये सर्किट अब बना रहेगा, ऊपर से नीचे तक कनेक्शन ही रहेगा। जब भी आप कनेक्ट कर, ये इलेक्ट्रॉन जो है ना आप ट्रैप हो गए हैं, उन्होंने ये ट्रांजिस्टर जो है ना इसको रीड कैसे करते हैं, उसके लिए आपको फिर वो इस तरह से होता है कि ये ट्रांजिस्टर आपका बेसिकली अगर इन्वर्टर आप देखें तो वो तो इस तरह से होगा। अगर बेसिक ट्रांजिस्टर देखना है या इन्वर्टर देखें तो ये होता है कि इस तरह से होता है, ये पी टाइप है तो ये एन टाइप। तो बेसिकली जब इसको नो वोल्टेज दें तो ये ऑन हो जाता है, उल्टा बिहेवियर होता है इसका। ठीक है ना, तो यहाँ +5 है, यहाँ वोल्ट ग्राउंड, तो ये ऑफ हो जाता है। यहाँ पे आपको +5 वोल्ट मिल जाते हैं, राइट। और जब आप इसको +5 देते हैं, 0 के लिए ये वाला रिलेशनशिप होता है। जब आप इसको +5 देते हैं तो ये वाले नेगेटिव इलेक्ट्रॉन जो होते हैं, प्लस इलेक्ट्रॉन, इसको ऑन कर देते हैं तो ये वाला जैसा ये ऑफ हो जाता है। तो इस केस में ये ओपन सर्किट, ये शॉर्ट सर्किट एक्ट करेगा तो यहाँ पे आपको 0 वोल्ट मिलते हैं और ये बहुत ही हाई क्वालिटी का शॉर्ट सर्किट होता है। only time so this way this CMOS transistor acts as a और ये जब ये ओपन है, ये शॉर्ट सर्किट है, कोई करंट नहीं फ्लो करता। इधर से तो वैसे नहीं कर रहा क्योंकि गेट के साथ कनेक्टेड है, so there is no current flowing in this direction. They are both insulated. So they insulated silicon dioxide की वजह से ये pure insulation है. Only the current that flows from here is uh, only when it is switching, and there is a time when it is off. This is turning on. So brief time both are on. Very brief moment of time. So we say that a short circuit current flows between them. So that's the only current, short circuit current. अगर आप इसको ऐसे ही रहने दें, no static input पे कुछ भी रखें, it will not no current flows. That's why CMOS circuits are supposed to be very low power, especially if there are very low frequency operation on power. हाई फ्रीक्वेंसी पे ये इतनी ज्यादा स्विच ऑन ऑफ होते हैं कि काफी दफा फिर इनमें से शॉर्ट सर्किट करंट फ्लो करता है। तो करंट फ्लोज व्हेन दे आर स्विचिंग, ठीक है। So this is the idea of this semiconductor. So uh, and also explain how this flash ROM is made. That it is basically the gate is insulated and from everywhere, and you apply very high voltage, electron penetrate into the gate, then they stay there for 20 years, and they kind of this situation में आ जाता है तो हमेशा का connection हो जाता है। All right, so this is the idea of this metal oxide semiconductor. The other topic that we want to learn, this is remaining after a little bit, and that is about how these memories are made. You may guys have seen these memories. This, for example, how many ICs it has? 8. Each one stores 1 bit. So combined, they can store 8 bit. Each one stores 1 bit. Here it can store 2 bits, so on. So if you search the IC number लेके internet पे search करेंगे, you will get a complete diagram, just like ROM. जैसा कि ROM की diagram है, उस तरह की आपको इसकी भी diagram मिलेगी. Exactly like that. तो ये कैसे बनते हैं, ये वाले IC? ये कैसे बनते हैं? Sorry, इनको कैसे जोड़ते कैसे आपस में? That is the topic. Just explain a little bit. The last topic of the lecture. So the idea is making, ये हमने पहले भी किया, making क्या नाम है, ये जरा देख लेना नादिर कि नजर आ रहा है या नहीं, थोड़ा सा कैमरा कंट्रोल। हाँ, all right. So what happens in a memory? If you remember, this is the symbol of a memory. It has a 2 raised power n multiplied by m size. So n means it has n dash lines and m data lines. It also has a read and write and chip enable. And all the data lines are tri-stated. When this chip enable is active, all these data lines are basically high impedance as if they are not there. So that today is a basically question is how to make a bigger memory given that this memory of certain size, how can you extend your memory? So like here, this is an example of how they have extended memories. This one over here. So you can see here, there are 8 chips over here. This used to be called single inline memory module, SIM. It was called SIM, single inline memory module, single inline memory module. Here, single, the 4 chips over here. These are, on the other hand, these have chips on the both side, as you can see. So they are called DIMM, dual inline memory modules, dual inline memory modules. So this is 100 old memory. In the beginning, memories were very expensive. Another example by different companies. Kingston is one of the biggest memory manufacturers. Kingston. So how, question is how to make a big memory using a smaller one. So the idea is, for example, to make uh, 4 megabyte using 4 megabit memory. So 4 megabyte means 4 million locations, but each location has 8 bit of data. Here 4 megabyte means 4 million location, each has 1 bit of data. So this gives you how many address lines. How do you get, how many address lines do you get here? As 4 power m, which is m is 2 raised power 20, multiply by 2 raised power 2, which is 4. So that gives you 2 raised power 22. So 4 megabyte is 2 raised power 22, means the dash lines will go from dash line will be 22 dash line going from A21 to A0. So this is same. So memory dash lines are same, only the data lines are different. So if you divide these data lines by this, you can see that we need 8 ICs, 8 ICs. So we have to make an array of 8 ICs to from this to this. So we need 8 ICs. So what you want to make is you divide that with the one you have available. So this comes out to be 8. 4 megabytes multiplied by 1, 8 ICs. So how do you make this IC? How do you make this memory array? One over here, you've seen this. These are ICs each of them has 1 bit memory. Or how they make this using 8-bit memory. So what they do is that they have 21 address lines coming. These address lines, you will notice, will go to all of the chips. This is a chip for 1 megabyte multiplied by 1 bit that will store our D7. This is 1 megabyte multiplied by 1. This will store our D8, D6. And these address lines go to all of them. So D0 up to uh, D7. So 8. So this will give D0 output. This will give D. ये देखना यार नादिर, लोग किधर है? कोई बताता ही नहीं है, नजर नहीं आ रहा। क्यों भाई? किधर है सारे लोग? हाँ भाई, ऑनलाइन पीपल, वेयर आर यू गाइस?
जी सर, हम हैं, देख रहे हैं।
तो कहा ही नहीं आपने कि सर नीचे करें, नजर नहीं आ रहा।
सर बताने वाले थे
नजर
बस।
आ रहा था थोड़ा बहुत।
अच्छा, सही है। So you have D0 coming from this D and so on, D1, D2, D3 coming from this, and they become an 8-bit data. So each IC is responsible to store just 1 bit. So if I store, for example, this memory, if I store in any location, at any location, some data, say 29 hex, which is equal to 00101001, then you can see D0, this memory will store this one. This memory will store 0, so on. So all of them will store their separate bit. They will act like this will act as a storage for D0, this will act for D6, this will act as for D7. So combine all of them, they will give you 8-bit storage. So this is called mental expansion. The other part is vertical expansion. So that is a little bit more interesting. And for that, you actually need an extra logic to make vertical expansion. So vertical expansion is when you locations. So here, for example, you want to make a 4 megabyte multiplied by 8. You want to make 16 megabyte multiplied by 8. So this is given. One chip is a 4 megabyte multiplied by, and you have to make a memory array of 16 megabyte multiplied by 8. So you have to see कि इसमें कितनी total address lines होंगी. Address lines here will be 22. Here, how many address lines are there? That will be 2 raised power 20, which is mega, multiplied by 2 raised power 4, which is 16. It comes out to be equal to 24. So 16 megabyte memory is actually requires, it has 16 million locations. So it needs 2 raised power 24 total memory locations. So for this, you have a dash line size of 24. So you can see there are two extra dash lines that we will use to make our vertical expansion. There are two extra dash lines. So what we do is we have four. How many ICs are needed? Divide again. 16 mag multiply by 8 divided by 4 mag multiply by 8. So this is equal to 4 multiply by 1. Means that 4 ICs we need to have in a vertical direction. 4 ICs we need. So we need 4 ICs of this size. So we'll make a symbol for these 4 ICs. We have this IC, which is 4M multiplied by 8. So it will have 22 dash lines given here. Same dash line go to all of them. Just like the decoder expansion, you remember how we used to make bigger decoder using smaller decoder? Exactly like that, we make a bigger memory array using smaller, bigger memory array. So it is exactly the same. So थोड़ा zoom कर देना नादिर. So this is the memory lay. This will have a as enable signal. Enable. This will have its own enable signal. This will have its own enable signal. And this will have its own enable signal. So this has its own data bus multiply by 8. So multiply by 8 dash lines over here, tri-stated data bus. This will have its own 4 multiply by mega by 8, its own data bus, tri-stated. This will have its own data bus, tri-stated. And this will have its own data bus, tri-stated. So since all of them are 8-bit data bus, so that's why you are using this tri-state very nicely. This tri-state property of these ICs, they become very handy. So this is the main data bus probably coming from the processor. This is 8-bit data bus. Now these are lines are A0. These are dash lines are A0 to A21. 22 dash lines. What happens to 20 dash line number 23 and 22? 20 to 21 are common to 23 to 22 go to a decoder. 2 to 4 decoder. 2 to 4 decoder. So this has the two remaining dash lines. This is A22. This is A23. So since this decoder has 4 outputs and they go to these dash lines over here. So these address lines make the enable of this. And remember, property of decoder, that the chemistry of decoder fits well with this, because at any time only one output of the decoder can be one. As a result, only one of these memory chip can be enabled, and its data bus will be connected to this main data bus. So only one of them will be connected. This decoder has enable also, so that will become the master enable of this whole setup. So if you don't want all of these memories to disconnect from this data bus, you can make this enable the zero. So they will are one, and they will all disable. All of them go into the high state because of these tri-state buffers. They will all go into the high state, and this data bus will become floating, uh, making ICE processor to communicate with another device through the same data bus. So this data bus probably is going to some other devices also. So once you want to disable this whole setup, you just make this enable equal to 0. They all become high stated, and none of them are connected to the data bus. So these two address lines are remaining address line that are basically used in the vertical expansion. मुझे समझ आ रही है इसमें? Just like we had expansion of decoders, exactly the same we have expansion of our memories. ठीक है? You guys agree? Quick question. Quick question.
No, sir. Thank you.
अब आप दोनों डायमेंशन में अगर एक्सपेंशन करनी हो तो वो कैसे करेंगे? फर्ज करें हमने 4 मेगाबाइट 16 मेगाबाइट बाय 16 बनानी है, तो फिर क्या करेंगे? Using this IC, you want to make 16 megabyte multiply by 16. So now we need 8 of these ICs. Total storage is basically area in between this 16 million location multiplied by 16. So when you find out you need a 4, horizontal expansion is found out by dividing 16 million divided by 4. You get 4. That means you need 4 ICs here. 16 divided by 8 means you need 2 ICs over here. So then these ICs, this data bus will become D0 to D7. You have to repeat whole of this setup again, just like we did in the last example when we were doing the horizontal expansion, that we can expand this data bus D0 to D7. We can have the same setup over here. Same setup over here. So same dash lines going to all of them same dash lines, because this is 4 megabyte multiplied by 8. So definitely it will need 22 dash lines. Now, since this is multiplied by 16, it means that it can store 8 bits at each location. That means 2 bytes at each location. So this memory chip this will store 1 byte, and the other one out of this over here, this will help in storing the other byte. So this will become 16-bit data bus. Processor is 16-bit. So in this case, so this will be D8 to D15. 16-bit data lines over here. So enable will be same. When you do vertical horizontal expansion, you have to have the same enable. So that one byte is selected in this memory location, one byte is selected in this location, or if the dash is such that this enable becomes one. So this chip is selected when the address A2, A3 is 00. This is when the dash 01. This is when the dash is 10, and this is when the dash is 11. So these are MSB bits of the address. Two MSB bits of the address that determine this. So this time, what when these two are 00, one byte will be selected from here depending on this 22-bit address, and one byte will be selected from here depending on this 22-bit address. So both of them will be selected simultaneously. This will give half of the cake will come from here, half cake. Half of the cake will come from here. So they are all connected like this. So you see, the processor can now read and write 16 bits of data. Uh, Half of this can be this. So setup is doubled. हमने अपनी जो है ना 10 मरले का घर था, हमने एक किनाल का घर बना ली. So now we have a house that is one canal. पहले हमारे पास 2 मरले का घर था. नहीं, 5 मरले का घर था. तो हमने 5 मरले के 4 घर बनाए, तो हमारे पास एक कनाल का घर बन गया. अब हमने 2 कनाल का बनाना है, तो वी रिपीट दिस होल सेटअप ओवर हियर. तो इसमें एक बाइट इसमें स्टोर हो रही है, एक बाइट इसमें स्टोर. एड्रेस सबकी गेट सबका एक ही है, थ्रू विच यू एंटर इनटू दिस बिल्डिंग. सबका गेट, सबकी एड्रेस लाइन सबकी सेम है. तो यू विल नोटिस दिस कि मेमोरी रेज में एड्रेस लाइन सबकी सेम होती है, ओनली डाटा लाइंस आर नेम डिफरेंटली. ये इसकी D0 D7 है, लेकिन एक्सटर्नली दे आर नेम D8 to D15. This is D0 D7, they are named D7. So D0 D7 from here, D8 to D15 from here, total D0 to D15, 16-bit address bus. So you have now a horizontal expansion and vertical expansion. Both of them are there. So a good example would be to see how an address is stored in this memory. This is a good question. Please do remember this because you may have something to be in the final exam. That if I give an address, so this is a 24-bit address, means 24-bit pointer. So if I give इधर कर दें थोड़ा सा. So if I give memory and give a direct address, कोई register नहीं है, direct address देता हूँ, 24-bit का मतलब कितने hex digits हो जाएंगे? 24 में कितने hex digit होंगे? 4 से divide करें. 6 hex digits. So let's say I'm storing this on this memory location, 6 A, B, C, D. So uh, 6 dash line E, and I am storing at this dash line a value of 16-bit 0x95. This is 8-bit value, 16-bit value 9524. थोड़ा सा देखें आ रहा है नजर. So 9524, this is an 8 byte, this is another byte. 16-bit value I am storing at this address, which is a 24-bit address. So this is a 4 plus 4, 8, 12, 16, 20, 24. So this address has the two components here. This 6 has a 0, 1, 1 0, and this address line is A22 and this address is A23. But the rest of this is 20-bit address. ये तो मैं बाइनरी में लिख देता हूँ, बाकी A, B, C, D, E is in hex. So these 10 ABC, this is a 20-bit address. This is 20-bit address, 22-bit address. Two address lines combined, this total become 24-bit. Now this 0 1, this 0 1 when it appears over here, इधर करें थोड़ा सा नाजिश. When 0 1 appears over here, that means this row will be selected. This row. This 0 1 means this IC will, this two rows will be selected. And this over here, the 1 0 ABCDE will be the address location between these two ICs that will be selected. On at that location, 95 is our D0 to D8 to D15, and 24 is D0 to D7. So this 8-bit of data, 95 will be stored in this memory location, in this chip, and 24 will be stored in this chip. आधा केक जो है ना इस 16 बिट के डाटा में से जो आधा केक है वो इस एक मेमोरी में जाएगा, 8 बिट का डाटा 95 है डाटा जो है वो इस MSB वाली मेमोरी लोकेशन में चला जाएगा, और बाकी आधा बिट का जो 24 है वो इस मेमोरी लोकेशन पे चला जाएगा. तो when it is stored here, you see data will come from this. Half of data will appear on this data bus, half of data will appear on this data bus, and it will be saved. One thing common to all of these ICs that I forgot to maintain, जो आपने लगाना है, वो है, वो क्या है जो सबको कॉमन है, वो है रीड राइट. रीड राइट क्योंकि रैम है ये, तो इन सब का रीड राइट भी सिग्नल होता है. रिमेंबर कि इसको रीड करना है या राइट करना है, डाटा सेव करना है या लोड करना है या स्टोर करना है. तो ये मैं अक्सर ड्रॉ नहीं करता, मैं सिर्फ ये शो कर देता हूँ कि छोटा सा यहाँ पे लिख के रीड राइट, आई जस्ट राइट हियर के रीड राइट गोइंग टू ऑल द आईसीज. तो ये एक ही लाइन होती है, प्रोसेसर ओनली हैव वन कंट्रोल रीड राइट that goes to everything in the processor. So there is just one read write signal that will go to the all ICs in the memory. So the read write goes to all the ICs. This read write. Remember read write भी तो होगा ना ROM के साथ. तो read write को मैं ड्रॉ नहीं करता, वो बहुत messy हो जाता है. I just say कि read write is नीचे स्टार डाल के लिख देता हूँ कि read write is going to all the ICs. So just remember that the read write goes to all the ICs. And this read write comes from the processor. Processor has this data bus, address bus, and read write. So these are the three things that processor needs to communicate with the memory. Address bus, किस जगह store करना है, data bus, what is to store, read write, when to store. So what, where, when. What is data, where is address, and when is read write. तीन चीजें चाहिए होती है मेमोरी को कि कब आपने डाटा स्टोर करना है, किस जगह डाटा स्टोर करना है, और क्या डाटा स्टोर करना है. These are the three things that you need. So this is the basic idea of the memory arrays. So if you read this article, you will find how these memory arrays are constructed. I am only going to I'm going to end my lecture here, and do read this lecture on memory arrays. And I've also shown you how CMOS MOS transistor works, and very interesting demo. I hope you like that. So with that, I will end my lecture. Thank you very much. and God bless you all.
Okay, sir. Allah Hafiz.